Make. The old school build system you will find everywhere. When it comes to build systems, Make should be a relic of the past, but is still widely used. So today we will have a look at Make. We will install all of the necessary tools and we will build our first program using Make. After that we will look at the more complex example. Hi, my name is Zen and welcome to my channel. So the first thing that we need to do if we want to start with Make is to obviously install it. We will do this again by using the package manager of Linux. So in this case apt-get. So we type in sudo apt-get install make. After that it will gather all the dependencies and it will set up everything that we need to get Make. So yeah, this already worked. So at this point we will have Make ready. So the first thing that we now want to look at is at the very basic example. So the basic example, here we have already a main.cpp file, and this main.cpp file, we want to build this one using Make. Because Make has already some predefined commands basically inside, for this simple example, we don't even need to create any additional files. So the only thing that we need to do is type in Make, define what compiler we want to use. So in this case, we want to use Clang++, and tell Make which file we want to compile. Then we hit enter and we see it did work, and we now have a main program which is outputting us here hello friend. So this already did work very nicely. We don't need to do anything, no Makefile required. It is just because of the already internally defined Make targets that Make has already. The second thing that we want to do is to have a look at the more simple example. So not the very basic one, but a simple one. Again, we do have here a main.cpp, but this time we do have a Makefile alongside that. So the Makefile is containing basically the recipe on how this thing gets compiled. And here we want to have a look at the most basic things that Make offers. So we are able to create also variables in this Makefile and assign specific values to it. So usually there are some variables which are already a little bit predefined, so you can have a look at them online. So for instance, CXX usually means in well-structured Makefiles that this is the C++ compiler. And also the CXX flags are the C++ compiler flags. In line 7 here we define the main target, which we can later use by just calling main. Here we define the dependencies. So main will depend on a single file, and that single file is main CPP. So whenever main CPP is changed, Make knows that it needs to rebuild this main file. And how can it rebuild the main file? It is by calling that command which comes here, which is the compiler, the flags, then -o main and main.cpp. Basically what we would also type in the console. The last thing is clean. This one is useful if you want to clean up everything that you have compiled. So let's have a look how this will look like. So we switch to our more simple example. And here the thing that we also need to do is to say Make. And here we basically have the choice now of 3 different targets that we want to make, all, main and clean. So we can just say, for instance, make all. And in this case, it will just run all, which depends on main. So it also will build main, which then calls this command. And this is exactly what we see here. Now the command has been run. We have our main executable. We can also run this main executable and then we will always output our stuff. And now we will clean this one up by calling make clean, which we have defined here in line 12. and we see that this one is just removing our output file. Okay, now that we are familiar with the more basic and simple usages of a Makefile, we will have a look at some of the quirks and let's say some of the inconveniences that Make has. Because you really need to be careful about using tabs and spaces in Makefiles. Usually a lot of people get this wrong. So for instance, if you now use spaces for indentation and just say that at this point you want to have it indented, then most likely it will complain about something like missing separator. So the error message is completely unuseful. But beware, if you see something like this, check whether you're using really spaces or tabs. Because you can also define what Makefile expects, so you can separate it, but it always requires either spaces or tabs, and you need to be careful about that. So I now have done it again, and now it works again. We can also tell Make to use a different file. For instance, if we want to have several different Makefiles alongside each other, you can pass this to Make by using the -f command and tell Make it should use now the Makefile 2.mk, and out of 2.mk to separate, I have renamed here the main target to main2, and I now want to build main2 out of it. And here you see that it also does work and will recompile it accordingly. Now the next step that we want to do is have a look at a very or a more reasonable, more complex example that might be like this in the real world. So for instance, we have here main.cpp file, but this is not alone. It has some dependencies. The first dependency would be the shape.h and the second dependency would be line.h. So we use here some classes which are defined in these files, and the files themselves also have an implementation in the CPP file. If we look here now at the Makefile, it gets a little bit more complex. So at first we also define again the compiler and the compiler flags that we want to use. This is very useful because you usually want to compile everything using the same flags. And this -g flag in this case is just adding some debug information to the files and to the output, so a little bit better to debug. The all target will just depend here on main, and here we see that we have now separated all of the steps from top to bottom on a dependency tree basically. So the first thing that we have here is main, and main will depend on the main.o, shape.o and line.o object files. These object files later on, we can also specify how those are being built. And basically the structure is always the same. It's the name, and afterwards it's the dependencies, and then it's how this will be built. So how what is the command that Make will execute afterwards. So we see we have here a nice dependency tree. Main depends on main.o, main.o depends on main CPP, shape and line, and line depends on line and CPP and line.h, and so on and so forth. And the clean command also has additional options now, because it doesn't only need to remove main, it also needs to remove the other object files. So let's now have a look in the console and make what we have defined here. So we will go to our more complex example and we will just call make. Because make without any arguments will always call make all. And here we see that all of the different commands are being done in the correct order. Even though we have specified this one as the first command, it will actually be run last because it depends on all of the other commands before. So we see we have compiled main, shape and line, and afterwards we have linked them all together using the same compiler and the same compiler flags. The beauty here of Make is that Make as a build system has automatically dependency tracking, and it also sees whether you have touched certain files in a dependency tree. This means it will only rebuild what really needs to be rebuilt. So for instance, if I now go to the shape.cpp file and for instance just touch it once, so I change a line, added the space, and to save this one again, then Make will realize that this file has been changed, but it will only rebuild now all of the dependencies of that file. So if I call now Make again, we will see that it will rebuild shape.cpp and afterwards relink main. But it won't recompile main CPP and it won't recompile line CPP, because those files and those targets, they don't depend on the file that I have currently changed. So this makes it very efficient and also very good to track the changes that you have been done. So from my side, that's all from today. Have a look at your Makefiles. You will probably discover some of them in the wild. You can turn on your machine and download the code that I've put here on GitHub, and you can tell me what you want to hear about next. And as always, enjoy coding.